Using the multiplication principle, we have calculated it in the form of 9 into 8 into 7. Now, how to write the same thing in the form of a permutation? If I replace m here, then I will be together. So, wherever they goes, they'll go together. So, here I have tied them as one single unit. Except p, the remaining letters are repeated. So, when we have a repetition of digit, we always divide the total factorial by the repetition of the numbers with their respective factorial. Hello everyone, a warm welcome to one and all. This is Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So here in this session, we are going to take up the problems on permutation. So let us see the applications of permutation. Now, how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? So using the multiplication principle, so we have learnt that if we need to form a 3-digit number, then we will take 3 units. So where we need to place 100 value, tens value as well as unit value. That is, if there are the digits from 1 to 9, so we need to form only 3-digit number so that none of the digits are repeated here. So using the multiplication principle, we have calculated it in the form of 9 into 8 into 7. Now, how to write the same thing in the form of a permutation? Now, we know that there are 9 digits, so 9. Since the repetition is not allowed, every arrangement is different. So, we are choosing only 3 numbers to form a 3-digit number. So, therefore, this is 9p3, which is equal to 9 into 8 into 7. So, the short form 9p3 can be written as 9 factorial into 9 minus 3 factorial. So, which becomes 9 factorial divided by 6 factorial, which means until 6 factorial, all the numbers get cancelled. We are left with only 9 into 8 into 7. So, we'll multiply this directly. So, thus, when you multiply this, you will get 504. So, therefore, 504 3-digit numbers can be formed using the digits from 1 to 9 without digits being repeated. Next question. How many 3-digit even numbers can be made using digits 1, 2, 3, 4, 6, 7 if no digit is being repeated? So, we know we need to find out 3-digit number. So, where we have a units place, tens place and 100 place. Remember, we need to form a 3-digit even number. So, that means in the unit place, we can have 2, 4, 6. That means we can fill only 3 numbers. So, there are 3 chances to place in the units place. Now, if suppose any one of the number is in the unit place, there are remaining 5 more numbers. So, that 5 numbers has to be placed in hundreds place as well as tens place without repetition. So, we have 5 numbers out of which we need to fill any 2 numbers. So, therefore, here, so number of permutation or number of arrangements or number of 3-digit numbers, everything is one and the same, is 5p2 into 3. Now, 5p2 can be written as 5 into 4. Now, here it is 3. So, therefore, 60. So, we can form 60 digits or 60 3-digit even numbers. Next question. Form a committee of 8 persons. In how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold than one position? Suppose we'll take a 2 position. So, the first position is for chairman and the second position is for vice chairman. We know that there are 8 persons. So, that means all the 8 persons can become chairman. If suppose one person is a chairman, then the remaining 7 persons has to be placed in terms of vice chairman. So, therefore, this can be used in the case of multiplication principle. So, it is 8 sevens are 56. But how to write this in the permutation form? So, a chairman means all 8 persons can become a chairman, but we need to choose only one. And similarly here, the remaining 7 persons can be opted for vice chairman, but we will choose only one person. So, therefore, it is 7p1. We know that np1 is equal to n. So, 8p1 can be written as 8, 7p1 can be written as 7. So, therefore, 56. So, therefore, So we can choose 56 ways of choosing a chairman as well as vice chairman. Next. How many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once? Now you can see here EQUATION. So we have 8 letters and none of the letters are repeated here. So we need to interchange their position. So we need to form a word with or without meaning using only these letters without repetition. So that means I need to take the permutation of all the 8 letters. So which is nothing but 8 factorial. 8P8, or we know the property that is NPN is nothing but n factorial. So therefore 8P8 is nothing but 8 factorial. So whose value will be equal to 40,320. So that means we can form 40,320 words with the letters of the word equation. Next question. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated if 4 letters are used at a time, all letters are used at a time, all letters are used but first letter is oval. Now here we can see there are 6 letters in the word Monday, but we need to choose only 4 letters out of 6 letters so that a new arrangement is formed. So therefore, how many number of words we can form out of 6 letters when only 4 letters are used at a time? So that can be represented in the form of 6P4. So here 6P4 can be written as 6 into 5 into 4 into 3. So the total number of words here we can form is 360. The next thing is we need to take all the letters at the same time. So there are 6 letters, we need to take all the 6 letters. So therefore, in terms of permutation, it means 6P6, which is nothing but 6 factorial. That means 6 into 5 into 4 into 3 into 2 into 1, whose value is 720. The next thing is they have said here, so we need to form a words where all letters are used at a time, but first letter is a vowel. So we know that there are 6 places here. 1, 2, 3, 4, 5, 6. So the first letter must be vowel. So clearly there are only 2 vowels here. So we can place any one letter out of O or A. So therefore the possibility of choosing vowels is 2. The remaining 5 places are there. And if one of the vowel is placed here, we are left with 5 more letters. So we need to choose all the 5 letters. So therefore here the total number of permutation can be written as 2 into 5P5. So we have 2 chances here. This can also be written in the form of 2P1. Out of 2, we need to fill any one vowel. So therefore it is 2P1 into, if I fill O in the first place, there are 5 more letters. And I need to arrange all the 5 letters. So choose all the 5 letters is nothing but it's a permutation of all the 5 letters, which is 5P5. So therefore this is 2P1 into 5P5. So again this will be 2 into 5 factorial. So that is equal to 2 into 120, which is equal to 240. So therefore I can form 240 words by placing an vowel in the first place and the remaining letters in the rest of the places. Next question. In how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? So that means I need to make an arrangement of the word Mississippi where all I comes together. So now here, first let us find the total number of permutation for the given word, that is Mississippi. So how many words are there? How many letters are there in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means arrangement can be done in 11 factorial. So first we will calculate total number of ways. So that is 11 factorial. We have studied in the previous session that if any one of the object is repeated certain number of time, we will divide the total factorial by the given number of factorial. Now here if you observe the word Mississippi, here I is repeated 4 times, S is repeated 4 times, P is repeated 2 times. So therefore, the total ways has to be subtracted by these factorial, because when you interchange S and S, it doesn't change the order. Similarly, P and P, it doesn't change the order. I with I, it doesn't change the order. So it will be of the same order. So we need to remove those numbers from the total ways. So that's why we'll divide this by 4 factorial, by 4 factorial, by 2 factorial. So if you simplify this, we'll get the value 34,650. Now my question is, I should make an arrangement where 4i do not come together. So first let us calculate where 4 i's come together. Now we have 11 places here. So what I'll do, I'll tie all i's in one unit. I'll consider them as one single object. So if I consider all i's in one unit, so how many letters are remaining? We have M, which is repeated one time. So I'm removing this. We are left with 4 plus 2 plus 1, so which is 7. So we have 7 more letters here, which has to be arranged. So wherever this entire I goes, it goes equally with the in between the other letters. So that means, so if I replace M here, then I will be together. So wherever they goes, they'll go together. So here I have tied them as one single unit. So now along with this unit, I have 7 more units. So total, I need to make an arrangement of 8 objects. And under the 8 objects here, we have a letter S, which is repeated 4 times, and a letter P, which is repeated 2 times. So here, number of arrangements where i's are together. That is equal to 8 factorial divided by, so we'll not consider here because if we change the places of y, it is the same arrangement. So we will just find the total arrangement, and in the total arrangement with the remaining 7 letters, we have a letter S which is repeated 4 times and letter P which is repeated 2 times. So again, if you calculate 8 factorial divided by 4 factorial into 2 factorial, so you will get the value of 840. Now I need to calculate the number of arrangements where I do not come together. So I know the total number of ways. I know the number of arrangement where i's come together. So if we subtract them, we'll get 4 i's do not come together. So therefore, number of arrangements or number of ways where i's do not come together. So that will be equal to 34,650 minus 840, which is equal to 33,810. Next question. In how many ways can 4 red, 3 yellow and 2 green discs can be arranged in a row if the discs of the same color are indistinguishable? So here we need to take the permutation of 4 plus 3 plus 2, 9 discs. So where the repetition of the same color is not allowed. So therefore, so number of ways here, since I need to choose all the 9 discs, so it is equal to 9 factorial. And since the repetition is not allowed, we need to divide by 4 factorial, 3 factorial and 2 factorial. So with the small simplification also, we can write here 9 into 8 into 7 into 6 into 5 into 4 factorial. And here we can write 4 factorial. And here 3 factorial is 3 into 2 into 1. 2 factorial is 2 into 1. We can cancel 4 factorials here. 3 2s are 6, we can cancel. Then we are left with 2 1s are 2 4s are. We are left with 9 into 4 into 7 into 5. So after simplification, the value is equal to 1,260. Next question. Find the number of arrangement of the letters of the word independence. In how many of these arrangement do the words start with P? Do all the vowels always together? Do the vowels never occur together? Do the words begin with I and end in P? So here let us count the number of words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total we have 12 words. And out of this, so here I is repeated once, N is repeated 1, 2, 3 thrice. Next D is repeated 1, 2 twice. Next E is repeated 4 times. Next we have P, which is repeated once. Next we have C, which is repeated once. Now first, before going to any equation, we always calculate the total number of permutation. So the total number of ways is 12 factorial divided by the factorial where the number of letters repeated. So which can be divided by 3 factorial, 2 factorial and 4 factorial. So I can write this as 4 factorial into 3 factorial into 2 factorial. The very first question is here, do the words start with P? So now I have 12 places here. The first place is fixed for P. Now out of 12, there are 11 letters which are remaining. So I need to make the arrangement of 11 letters, and under these 11 letters, except P, we have a repetition of N, D and E. So therefore, here the total number of ways will be 11 factorial by 4 factorial by 3 factorial by 2 factorial. Because except P, the remaining letters are repeated. So when we have a repetition of digit, we always divide the total factorial by the repetition of the numbers with their respective factorial. Next we have do all the vowels always together. So first let us count how many vowels are there. We have I, so we have I 1 and we have E 4. So that means we have 5 vowels here. So let us tie all of them in one single unit. So second one, all the vowels to be together. So I'll write it as I, E, 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 E. So this is one single unit. So now the 5 letters are removed from the total letters. So how many more letters we have? So we have 7 more letters. So wherever this unit goes, it goes together. So that means we need to make an arrangement of one single unit plus 7 letters. So we have total 8 units for the arrangement. Now let us keep this as it is. Let us check the remaining 7 letters. So what are those 7 letters? That is N, D, P, C. And in that letters, we have a repetition of N and we have a repetition of D. So therefore, out of 8 objects, we have 8 factorial divided by 3 factorial into 2 factorial. So now the total arrangement is done. Now let us come back to this unit. So here we have 5 letters. And we can arrange all the 5 letters. If I comes in between, there will be a different arrangement. So we will choose all the 5 vowels. So therefore, the total factorial is 5 factorial. But we know E is repeated 4 times. So therefore, this is 4 factorial. So therefore, the total factorial where all the vowels come together with other letters is 8 factorial by 3 factorial, 2 factorial. So this represents the arrangement of 8 units with the repetition of letters into 5 factorial, 4 factorial. This represents the repetition of vowels here. Next we have, do the vowels never occur together? So we have done the problem here. All the vowels occur together. So we got the answer. So if we want the vowels not to come together, then we need to subtract by total number of ways. So therefore, the answer for this will be 12 factorial divided by 4 factorial, 3 factorial, 2 factorial minus 8 factorial by 3 factorial, 2 factorial into 5 factorial divided by 4 factorial. So evaluating this, we'll get the number of ways for the required result. Last question is, do the words begin with I and end in P? So we know that there are 12 letters. So out of 12 letters, the first letter should be with I and the last letter should be P. So these places are fixed. Now how many letters are remaining? We are left with 10 letters. And the number of arrangement we need to take for 10 letters is 10 factorial. But among those 10 letters, we have N which is repeating, D repeating, E repeating. So therefore, the total factorial has to be divided by 4 factorial, 3 factorial into 2 factorial. So this represents the number of permutations of the words begin with I and end with P. So in this session, we have taken many cases of permutations. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.